Assalamu alaikum. My dearest students, hope you are getting well. Today I have brought a topic for you, and I hope that it will definitely help you to understand this topic. Today's topic is a simple harmonic motion. To understand this, we study an example which is horizontal mass spring system. Again, I repeat, horizontal mass spring system. If you look at these diagrams of horizontal mass spring system, it will clear to you how easy it is. At first glance, spring is in normal condition where force is zero and mass is attached to this spring. Now the second figure shows that the force is applied to the mass due to which the shape of the spring has changed and the mass moved away from its center, means from its mean position. And when you remove the force, the spring moves fast and shrinks. Even then, it moves away from its center. You can see in third diagram. This process will continue for a while. From this example, you can easily understand how easy this topic is. There are two main points in this whole process. What you may have noticed is that each time the mass passes through its center during movement and its distance are always equal. That is to say, a movement that is constantly being performed to here and there of its center, known as periodic motion, and periodic motion is basically a simple harmonic motion. Simple harmonic motion is a to and fro oscillatory motion in which acceleration of the body is directly proportional to the displacement of the body from the mean position and is always directed towards the mean position. It means that when we apply a force on the mass which is attached to the spring, and spring is an elastic spring. And in the whole process, a Newton's second law of motion is also applied. A Newton's second law of motion is stated that when a force is applied on a constant mass, an acceleration is produced in the same direction. In this process, in a simple harmonic motion, according to the Hooke's law, this force is directly proportional to the change in length of the spring. The change in length is represented by x. So the equation is F is equal to minus kx, where k is a constant called spring constant. K, the value of k is equal to minus F upon x. According to the Newton's second law of motion, we will apply the Newton's second law of motion. We replace the value of F. So we replaced the value of F and put its value. So therefore the K is equal to minus ma upon x. From this equation, we can get the value of acceleration. So A is equal to minus K upon m to x, where k and m, these are the constants. So we will remove the constant, so we will put the sign of proportion. So the equation will make A is directly proportional to minus x. It means that in simple harmonic motion, the direction of the displacement towards its mean position. So minus sign shows that towards its mean position, where the restoring force is produced during the whole process. And what is the restoring force? A restoring force always pushes or pulls the object performing oscillatory motion towards the mean position. Basic conditions to execute simple harmonic motions. Number one is there must be an elastic restoring force acting on the system. It is a very necessary point. The number two is the system must have inertia. Inertia means the spring should be deformed. When a force is applied on an elastic object, after the application of the force, that elastic object should be deformed. The third point is A is directly proportional to minus x. So many examples are a simple harmonic motion. Uh, Elastic spring is the example of simple harmonic motion. Simple pendulum is the simple harmonic motion. Chord of guitars is the example of harmonic motion, and prongs of a tuning fork is the example of harmonic motion. I think you realize that this topic, inshallah, we will see again with other topics. May Allah live you long and keep you safer from pandemic and keep you healthier. Ameen.